All right, chapter 2, we're up to, and we're going to talk about load lines. So load lines, it's vital for the safety of the vessel that it should maintain adequate freeboard at all times, and this means that a vessel should never be overloaded. Due to varying different sea conditions in various geographical locations around the world, and then also considering seasonal changes, the marine authorities have created various zones to determine the minimum freeboard that a vessel must maintain depending on the zoning of the vessel's geographical location and the season of the year where it is operating in that location at the time. Marine authorities assign freeboard to vessels on the basis that certain conditions are met. These conditions of assignment are regulations to ensure that the vessel is provided with efficient means for satisfying the following criteria: protection of all openings to the hull and superstructure, protection of crew in heavy weather, and the rapid freeing of water from the weather decks. Freeboards are only assigned when the marine authority is satisfied that the vessel complies with the conditions of assignment that are applicable. Conditions of assignment deal with the following topics: stability, bulkheads, access openings in bulkheads, cargo and other hatchways, hatchway covers, protection of openings, ventilation coamings, air pipes, cargo ports, discharge inlets and scuppers, side scuppers, guardrails, and loading information. So you might have seen a few of these load lines on ships, definitely on cargo ships, but the C of A means the Commonwealth of Australia. And then on the other side, we've got down the bottom is the winter load line, the summer load line, the tropical load line, and then on the left-hand side of that line, the freshwater load line and the tropical freshwater load line. Now, these are all got markings that have to be a certain width and dimensions, and they're welded on the side of cargo ships so that we don't go and move them around when we go back into docks. We don't have to remember for the Master 35, we don't need to remember those particular measurements and how big they are, but they're there for your information. Australia have different zones, which is all to do with the weather throughout the year. So you're in the tropical zone right up the top part of Australia and down to Whitsundays. You can see that you probably imagine the weather up there is beautiful and calm most of the time of the year within the Whitsundays down the coast there. So they can load up their vessels to the tropical zone on there. So they can put more cargo on because they're going to be deeper in the water, but they're not going to be subjected to heavy and violent weather, as opposed to us here in Tasmania, down the southern part of Tasmania. The weather gets pretty ordinary down there. So you're not loaded up as much. So you've got that extra stability in case the weather is poor. If a vessel is floating without list in still water of a relative density of 1.025, the low line mark on either side of the vessel that is appropriate low line at that time would be submerged. It is considered an offence if an overloaded vessel goes to sea and the deck line and low lines are not marked or incorrectly marked. In order to prevent overloading, it's necessary that you should know the draft of your vessel for a particular displacement and the amount of change in draft when weights are added or removed from a vessel, and the allowance that should be made when the vessel is floating in water other than a relative density of 1.025. So I've got two pictures here. The one on the right is the bow picture of our training vessel, the Bluefin, which is a 35-metre training vessel here at AMC. On the left-hand side is a diagram showing the waterline just touching the bottom of the 1.6 metres. So the waterline is just touching the bottom of the 6 after the 1 metre mark. Therefore, the draft is 1.6 metres. If the waterline was just touching the top of the 6, the draft would be 1.7 metres. If the waterline is not exactly at the top or the bottom of the number, you need to interpolate by the eye to get the draft reading. For example, if the waterline was exactly at the centre of the number 6, the draft would have been 1.65. If the vessel's aft draft is greater than its forward draft, the vessel is said to be trimmed by the stern. If the forward draft is greater than the aft draft, the vessel is said to be trimmed by the head, and the mean draft is the average of the fore and aft draft. Trim is the difference between the forward and aft draft. So a vessel has a 3.2 metre draft forward and a 3.6 metre draft aft, what's the mean draft and the trim of the vessel? So the pretty simple calculation here, mean draft is the draft forward plus draft aft, divide by 2. So 3.2 plus 3.6 divided by 2, you've got a mean draft of that vessel is 3.4. The trim is the draft aft minus the draft forward. So it's 3.6, subtract 3.2, and it's 0.4 metres by the stern. So there's a port side photo of the bluefin there. You can see the pencil mark up forward, and then your aft draft markings down there on the stern area of the vessel. There's a couple of activities for you to complete as we go through today's chapter 2. If a vessel's draft is known, the displacement can be obtained from the hydrostatic particulars, and the hydrostatic particulars are usually provided in the form of a table in the vessel stability booklet, which is what you used in chapter 1 to do our TPC. So we know that it's got our drafts in there and our weights and our TPCs. And there we have a simple activity there from using the hydrostatic tables in the FV mark. How can we use the hydrostatic tables to determine how much cargo or ballast to load or unload to achieve a desired draft? So the bluefin is floating at a mean draft of 3 metres and the trim is 0. How much cargo can be loaded on the vessel so the mean draft does not exceed 3.3? So you could go to the hydrostatic particulars, you look at the draft at the moment, it sits at 3 metres and it weighs 407.5 tonnes. And at 3.3 metres, the weight would be 480.1 tonnes. So how much cargo can be loaded to get to 3.3? It's just a matter of doing that calculation. 72.6 tonnes can be loaded on that vessel to get it to a draft that doesn't exceed 3.3. Activity 2.3 there for you. We don't use TPC when we're loading and discharging a large amount of weight that has a significant change on the vessel's draft. TPC is only used for doing small amounts of changes. All right, so now we talk about the saltwater and the freshwater allowance on a vessel. So freshwater allowance, or FWA, is the number in millimetres by which the draft of a vessel changes as it passes from salt water to fresh water. So the arrow there, the upper edge of the saltwater mark, indicates the draft to which a vessel may be loaded when floating in salt water with a relative density of 1.025 in a summer zone. The upper edge of the F mark indicates the draft which a vessel may be loaded when floating in fresh water with a relative density of 1.000 in the summer zone. If a vessel was loaded in fresh water up to the F mark in the summer zone, a vessel will automatically rise to the saltwater mark when it goes into salt water, and the distance between the upper edge of the S and the upper edge of the F is the vessel's freshwater allowance in millimetres. So suppose a vessel is floating in dock water of density that is neither fresh nor salt water, but somewhere in between. In this case, the vessel can submerge its summer mark by the amount known as the dock water allowance, or DWA. The vessel will then automatically rise to the summer mark when it goes into salt water. Dock water allowance depends upon the density of the water that the vessel is floating in, and therefore you determine the density of dock water before you can calculate the dock water allowance. So the S mark, sorry, I'm just going to clarify this. The S mark is the summer mark on the side of your vessel, and it's also commonly known as your saltwater mark. So if you do a bit of research on it, some people call it the summer mark, some people call it the saltwater mark. It's neither here nor there, but the S mark is so you might be a bit confused why I just call it two different things, but they are both exactly the same. All right, so we want to try to work out the density of our water. So if it's somewhere between fresh and salt, we use this hydrometer. So we drop it into the liquid, the sample that we've taken, and we can read it off the hydrometer. Much like when you're brewing beer and it gets to the day when you can bottle it, the hydrometer in that case will tell you, but the hydrometer is for water. So fresh water is 1,000 and salt water is 1,025. So somewhere between that is called dock water. So this video is a large ship taking a sample of the water that they're actually sitting in at the moment. And to do that, they've got to drop that hydrometer below the first few feet of water, because fresh water sits on top of salt water. So they need to get the sample from down lower. No good taking a sample from just at the surface, because it won't be the correct reading. So they've got to drop it down anyhow. It goes for a little minute, but just have a watch that one.
The standard hydrometer in our office.那个簿上面也有。1.1.022了啊，1.02 1.022，你这同我啦，你同我，我话哦，哦 ，OK， I let you know. Yeah.
All right, there you go. So his measurement there was 1.022. So just a little bit of fresh water in that in where that vessel is docked. For any density between salt water and fresh water, a vessel can submerge its saltwater load line by an amount that is directly related to the density of the water. So imagine a hydrometer alongside the load line, as you can see by that little diagram there. The distance between the 1,000 and the 1,025 marks on the hydrometer can be regarded as the hydrometer's freshwater allowance. If both the hydrometer and the vessel were floating in fresh water, the water line would be at the 1,000 mark on the hydrometer and at the top of the F mark on the vessel. If both the hydrometer and the vessel were then transferred to salt water, the water line would be at the 1025 mark on the hydrometer and at the top of the salt water mark on the vessel. The distance between the 1000 and 1025 marks on the hydrometer can be regarded as the freshwater allowance of the hydrometer. In other words, we can say that the freshwater allowance of the hydrometer is 25 units. So 1025 subtract 1000 is 25 units. These 25 units correspond to the vessel's freshwater allowance of 50 mils. So that last bit, the 50 mils, so every vessel has a different freshwater allowance, but the distance between the summer load line and the top of the freshwater load line on the draft marks of this particular vessel at the moment is 50 mils. But the vessel you'll work on would be different than that. But in the examples in the book and in stability in this chapter, they always give you what the freshwater allowance of the vessel is. So that's the distance between the top of the summer load line and the top of the freshwater. So if you're on the side of your boat and you had a ruler and you marked between those two, that's what your freshwater allowance would be. So here it goes. It goes from freshwater, heads out the river, and then the water starts to become brackish. You can see that the ship's draft is changing. The hydrometer is changing with the draft because the water is somewhere between fresh and salt. And then when we get out to sea and we're in the salt water, then we'll be at the top of the summer load line. And the hydrometer would say 1025 because that would be the density of the water. So here we have a boat in a bathtub, and you can see that it's full of salt water and just sitting there, and the hydrometer would read 1025. We then open up the valve, hopefully in a minute. Maybe I need to get this thing started. Here we go. There it is. So it's sitting at 1025. Top of the summer load line. We then open up the valve and let a bit of fresh water in there. There it goes. And now the water is somewhere between salt and fresh, so it's brackish. As more fresh water is pumped in, the vessel's draft changes until it's fully fresh, and we're at the top of our freshwater load line, and the hydrometer would read 1000. We turn on the salt water and we do the opposite. We start pumping it up with salt water until it's 100% salt water. We'll be at the top of the summer load line and the hydrometer would read 1025. There you go, and that's what happens when you go out to sea. So if a vessel is floating in dock water of a density of 1.010 tonnes per cubic metre. So the freshwater allowance of this vessel is 50 mils. So you've got 50 mils between the top of the summer line and the top of the freshwater line. And we know that the hydrometer reads 1010. So there's 15 units left between 1010 and 1025. So by what amount can a vessel submerge its saltwater load line so that it's not overloaded? So that the conversion for it is, we're trying to find the dock water. So dock water equals freshwater allowance, divide by 25 because there's 25 units between 1000 on the hydrometer and 1025, and times by 15 in this case, because at the moment there's 15 units between what the hydrometer reads and the salt water on the hydrometer 1025. So our freshwater allowance is 50 mils, and we divide that by 25, and then we times by 15, and I was just doing it on my calculator. So the answer to that question is 30 mils. So we can submerge our saltwater load line by 30 mils. And then when we go back to C, out to C, it will rise and we'll be sitting at the top of our summer load line. All right, so the amount by which saltwater load line can be immersed in dock water allowance corresponds to the number of units between the water line and the 1025 mark on the hydrometer. And in that case, that was 15. All right, so there you go. So that's the way to do it. There's a few different examples on different ways that you can come to the same answer. But sometimes the little picture I put in front of you there is a simple way to do it. So there's some other ones to get to the same answer of 30 mils. All right, so this one, a vessel is floating in salt water with a specific gravity of 1.021 tons per cubic metre, and the vessel's freshwater allowance is 30 mils. So this one, they're saying there's only 30 mils between the top of the summer load line and the top of the freshwater load line. So the distance between there with the ruler on the side of your ship would be 30 mils. The specific gravity of the water is still the same. It's still 1,010. So there's 15 units. So its freshwater allowance would be 30. Divide by 25 times by 15. Let me just have a quick look at that one. So we've got 30. Divide by 25 times by 15. You should get about 18 millimetres. So you can submerge your summer load line by 18 millimetres. All right, so there's a few of those in the progress check to do, so you get a little bit competent with them. But if you follow that formula, it should be fine. So make sure you do all those examples. So I've got something to review, and then we'll move on to chapter 3. Thank you.